so Thomas, we are doing 3B, and I meant to make their little stars right here, and they're not there. So, okay. So, this problem gives us this function, f star. It's like having a g of x, or a f of x, or h of x. The f star tells you to do the limit as h approaches 0 of f of x plus h minus f of x minus h all over h. Alright, so think of these, your h, these problems are a lot like delta x problems. So they're like delta x problems. Okay, so think of that h kind of like it's a delta x here. We've done some delta x's before. So it's telling me for part B that I'm supposed to find f star of x for f of x equals cosine of x. Okay. So what I have to do for this is I have to find the limit as h approaches 0 of f of x plus h minus f of x minus h all over h using the function f as cosine of x. So I'm just going to write this over to the side here. F of x plus h in this case is going to be cosine of x plus h. Right? We're just plugging x plus h into the function. And f of x minus h is going to be cosine of x minus h. Because this part, when we're finding, like if we're finding f of 7, it just means plug 7 into f, right? So we're finding f of x plus h, it just means plug x plus h into your equation. So like when you do part A of this, you'll find f of x plus h and f of x minus h, and you'll be plugging into x squared plus x. Okay. So this piece right here goes right here for f of x plus h, and this piece right here is going to go right here. So we're going to have the limit as h approaches 0 of cosine of x plus h minus cosine of x minus h all over h. It could possibly, it's not going to be on the test tomorrow. It could possibly be on the free response quiz on Monday. I will take, you got 1, 2, 3, 4, 5, 6 different pieces of a function here. I'm going to take 3 of those. So you got a 1 out of 2 chance that I pick this one. And I do like actually just randomly select them. Like I'll write them all down on a little piece of paper while I'm just pick 3 out. I could do the spinning wheel. I might do the spinning wheel. It is just the name of this limit. So they could have called it like h of x, or they could have called it z of x. They called it f star of x. So if you're finding f star of something, it means to take the limit as h approaches 0 of f of x plus h minus f of x minus h all over h. So it means to do this formula here. Okay. They have told, it does not mathematically mean something like in all cases, but in part, like in the beginning of question 3, they tell you let f star equal limit as h approaches 0 of all of that stuff. So they are defining f star as that function. They could have used a g. They could have said let g of x equal the limit. They could have used something else there, but they just used the star. So this was actually So, there is something that you need to know to do this problem that your sorry pre-calculus teacher did not teach you. Yeah. It's me. So, if you had a better pre-calculus teacher, you would know the sum and difference formula for cosine. So, cosine of A plus or minus B equals cosine of A cosine of B minus or plus sine A sine B. When you have the plus or minus here, over here you have a minus or plus. What that means is if you have a plus here, you want to use a minus here. And if you have a minus here, you want to use a plus. So you're going to change whatever sign. Now, when I used to be a better pre-calculus teacher, and I actually taught this back before COVID hit, and I gave up on rigor. So back when I used to be a better pre-calculus teacher, I had a little song for this. I think Miss White taught it to me. I didn't come up with it. Somebody taught it to me. It's the cosine conga. And so it goes like this. Cosine, cosine, sine, sine. Don't forget to change the sine, sine. So, like if you ever have, and you can, if you do your arms, it helps. You know, like cosine, cosine, sine, sine. Don't forget to change the sine, sine. So I will, because your pre-calculus teacher was sorry and it's not your fault, if I give you this problem on the actual quiz on Monday, I'll give you the formula.
That doesn't mean I'm going to get it right, though.
So I'm not going to I might still put it on there, but I will give you the formula if I give you this.
You're going to give it to us and we're not going to know how to use it.
Yeah, so if you don't know how to use it, you're still out of luck, but I will give you the formula. So what you're going to have to do here, and this is going to make for a long problem, is you got to do the limit as h approaches 0. Oh, cosine of x plus h is going to be cosine, cosine, sine, sine. We're going to do x here, h here, x here, h here. Don't forget to change to the sine. It's right here. That's just the first part. Minus cosine, cosine, sine, sine, x here, h here, x here, h here. Don't forget to change to the sine. There's going to be a plus right there. All over 8. Yeah, it does. Yeah.
Just like that.
So all you're doing here is you're using this formula. So instead of doing cosine of A plus B, you write cosine of A times cosine B. Change the sign. So like here where I had a plus, I changed it to a minus. And then sine X and sine H. And then over here you do that same thing. And I will give you this formula if it ends up being on the quiz. All right. Yes.
This is like trig. Can we just guess 0 or 1 and be?
No. The answer is not 0 or 1. So.
Wait, I have a question.
Yes.
So this extended is the extended version of what's right above it?
Yes. Yeah. It's called the sum or difference formula, and it's like if I had taught this part to you in pre-calculus, we would have learned this whenever we learned like sine squared plus cosine squared equals 1 and all of that trig identity sort of stuff. But I skipped it. So
You're just like putting the x.
Wait, is this all cancel?
yes.
This is all.
Not everything cancels. So you're going to have cosine. Let's see. Don't forget my limit notation.
No, they don't. Except for 1.
Cosine
You
x
distribute the negative.
cosine h minus sine x sine h minus cosine x cosine h minus sine x sine H all over H. And so the expressions with cosines are going to cancel because you have a positive and negative of it. So I got two of these. There's like a 1 here and a 1 here. So you're going to have the limit as H approaches 0 of negative 2 sine X sine H over H.
Okay, can we just have like an agreement where this isn't going to be on the test?
Nope. So it's a fake.
Why is there no plus sign between the signs, but there's a plus sign?
Yeah, distribute this negative here.
No, I mean like above that. Like there's a x plus h, but then it's just sign x and sign h.
That's just the formula. So when you use this formula, it's going to be like the cosines here multiplied. So cosine x, cosine h. So like here, because you have an x and an h in the formula, it's like your a is an x and your b is an h. Yeah. So yeah, we completely replace it. So this equals this jump, and this equals this jump. So we did learn how to do this from here, but I'm gonna be honest. When I was working out the key, I had to look back at my key from years before to be able to remember this because I felt bad that I forgot what I was doing.
The two signs cancel out, and then you just have negative 2xh, and then the h's cancel out.
Signs don't cancel.
You convert them to cosine and add it.
You can't convert them to cosine. All right.
Oh, that equals.
This is a special limit. This equals 1. So we can write it like this. The limit. How many of you forgot that? Yeah, me too.
Well, you can't do it if they're adding, right?
No, I'm lost.
Right, you can't do that if they're adding, but because everything's multiplied, we can break them apart. Okay, so this right here is a special limit, and it just equals 1. All right, what are we going to get when we plug in 0 for our h here?
0. Sine of 0.
There, okay, Laura has an excellent question. Where's the h? There is no h. There's nothing to plug in here. You get negative 2 sine x, which is what you need. Because the answer to this is negative 2 sine x.
So there's no actual.
There's no number answer.
Now, where you circled the sine h over h, do we need to rewrite that, or can we just like cancel it out?
I can live with it if you don't show the step where you write it separately. Yeah, if you just write negative 2 sine x, like you just put equals, yeah, you're not going to need credit for this. Yeah, it doesn't work.
Not even 1 out of 4. We should I wrote everything down. Oh, that's better.
Okay, so this will not be on your test tomorrow, but it could possibly be on the free response quiz on Monday. I have also posted my solutions for the free response questions, I believe. Yeah. So you can check your work there. I've got 2 opportunities for you to ask questions. So tomorrow, since I am not going to be here, and you guys need the entire class period for your test, or you may run out of time. So since both of those things are true, I am going to have virtual office hours tomorrow morning. So I've got the meeting set to start at 7:45, but I do have to get through Caroline, drop Hunter off, and get back to the house. So if I'm not right there at 7:45, I'm gonna try to get up and get early in Caroline, but sometimes I have big plans and things don't happen like that. So hopefully I'll be there at 7:45, but like definitely by like 7:50 or 7:55 I'll be there. But yeah, Selena's gonna come by the house and take Hunter for me. But once I have dropped him off and got back, I will have office hours from 7:45, hopefully, until 9:45 because I've got planning first period. So I know some of you have a first period you have to be at, so that's not gonna work for you. And then I know also some of you are gonna be driving to school, so I'm not sure if it'll help everybody, but I will be available if you have questions that you want to ask. And then I will also on Monday be here for a smart breakfast. So if you have questions about the free response questions that you need to ask, you can also come during smart breakfast on Monday also. So I think I have already sent you an email that has that link to that Google Meet, and I'll just try to keep it up. So I'll be there if you need me. Tomorrow, though, Ms. Hendricks is going to get you started on your test as soon as you come in. You got 3 sections. First section is going to be calculator active multiple choice. It's got 5 questions on it. Second section is calculator inactive multiple choice. It's got 10 questions on it. And then you have, for your response section, it is all calculator inactive on the free response. And it will have 3 questions. 3 free response questions, so they'll have cards.
This is tomorrow. Yes.
Yeah, it'll be a lot of that stuff. For the test, I'm going to tell Miss Hendricks so that she reminds you as well. But what I'm going to do is I'm going to let you work at your own pace. But I would suggest 15 minutes for the first part, the calculator active with 5 questions. 30 minutes for the multiple choice. So altogether 45 minutes for that multiple choice part. And then leave yourself 45 minutes for the free response. That's roughly what they would give you on the AP exam. Yeah, so you want to spend half your time on multiple choice, half your time on free response.
So once we submit it, we can't, like, if there's any time left, we can't look back over anything?
No, it's on paper. But once you have turned that part in, you can't go back and get it. But do not run out of time for that free response part. Because if you become obsessed with the multiple choice section and end up with only 20 minutes left for 3 free response questions, you will not get them done. At least 40, I'd say. Yeah. So I will tell Miss Hendricks to announce when 15 minutes is up and announce whenever you should move on to the next section. I'm not gonna have her pry it out of your hands because maybe you just need 3 or 4 more minutes on the multiple choice and you'll make up for it later, which is fine. But if you're taking a lot longer on the multiple choice, you need guessing on. When I grade it, it's going half of the points are going to come from the multiple choice, half are going to come from the free response. So it's going to be half and half on the grading. So you want to make sure you got time to get to that free response. I don't think we need to. Yes, it'll be similar to your quiz, except for the questions will, instead of being disjointed pieces like you had for the first part, it'll be more like that second question where they all kind of go with the same thing. Yeah, so you'll have 3 different ones like that.
Okay, tomorrow we come into class. Will you be on a video call at all?
No.
So we'll just go straight into
Right, because you need an hour and a half to take this test. So I don't want to do that and take away 10 or 15 minutes of what time you need to do the test.
And if I going to straight today, which one would I start?
Progress checks are really good to look back over to see if you can do
Is it
those.
the one that we most recently did?
All of them. Yeah, all of them. I made up a few, but they're similar to AP Classroom stuff. most of them came from release tests, but I did make up a few just because there's not enough of these questions.
Once we go over the review, that'll pretty much get us pretty good.
Hopefully.
Okay.
Hopefully it'll be pretty good. Alright, so, I'm going to pass out this review here, but we're going to go over the progress check because there were quite a few yellows
Dude, I bet all
on
this
that
like a
progress
pro
check.
Tommy online.
Huh?
Tommy online.
This is the story.
He's not online, but I am recording.
Oh,
So that.
what a bad student.
Yeah, at least Louise showed up.
Yeah, for real. Let's go, Louise.
Well, I didn't give him a link or anything because
It should have been.
I just did.
You should, when he comes to class.
Because I knew we weren't doing like notes or anything.
Yeah.
Be like, why didn't you join
Next
us?
time
Where
you
were
see
you?
Yeah, next time you see the face.
Oh, sorry. Sorry about that. Here it is.
Oh, dude, I thought you were still.
Okay, we're gonna work on this in a minute, but we're gonna go over the progress check first. However, if I'm going over a progress check question that you already know how to do and you want to work ahead quietly, not talking, we got it. It's there.
Wait, so do we have to finish this tonight?
I'm sure there's
Yeah,
a-
14 questions.
I'm sure there's a test.
Do they have to be right?
Preferably they'll be right.
This what
I'm
the
hoping we'll get most of it done during
Is
class.
this what the test is going to be?
So is this the line?
Yeah.
Alright, so what you need to know about test and calculus. In earlier classes you have been spoiled. Where I give you, in class I give you 2x plus 7 equals 10. And then on the test I put 2x plus 8 equals 14. It's the same question, right? So, you know, we have covered everything that's going to be on there. It's not like these questions are going to be worded exactly like what you see, but these are just what I did mostly is I looked through the test, and I looked through and thought like, what are some things I think we need a little more practice with? So that's where these questions came from. You can see I made up some of them, and then some of them are pulled from AP Classroom. So you'll see that there. Yeah, because everything's been Unit 1 so far.
Oh,
So
no.
everything
We got to do that
is
speed.
there. So
Wait, no. Remember the speed? Oh, that's sick.
yeah, I figured we probably need
The
to
speed,
review that a
like the
little
thing
bit.
we did in the
Now
first
let's
week.
go.
Yeah. Okay. This unit is too long. I could do it in about 12 days if I had taught you limits before. Alright, I didn't mean to do that.
Decent.
I'll tell you how you did.
Let's go.
Alright, let's look at number 1. Okay. So for this one, you have discontinuities anywhere the denominator equals 0. So even though this cancels out and you got absolute value bars, it's going to be a jump. It's not a vertical asymptote. But anywhere the denominator equals 0, you have discontinuities. That means x squared minus 3 equals 0 and x plus 0.5 equals 0. So at x equals negative 0.5, you have a discontinuity. So that's going to take out b. It's not going to be continuous there because negative 0.5 is between negative 1 and 0. Whenever I solve this, I'm going to get x squared equals 3. And I'm going to square root both sides. So x is going to equal plus or minus the square root of 3. Now this is calculator inactive. So you can't type square root of 3 into a calculator to know what it is. But what's the square root of 1? What's the square root of 4? So square root of 3 has got to be somewhere in between 1 and 2. So it can't be between 1 and 2. And it's also got that plus or minus, so it can't be between negative 2 and negative 1. So it's got to be C, because you don't have any discontinuities from 0 to 1.
So those parentheses are not
Right. So, and it says, which of the following open intervals right there is what tells you that those are not points, they are ranges. Yeah. They're like, you have, right here you have a hole at negative 0.5, and you're actually, with those absolute value bars, you actually get like a jump in the graph because of those absolute value bars there. But it really doesn't matter what type of discontinuity, because a hole is still a discontinuity. So holes, vertical asymptotes, jumps, any of those are still discontinuity. So the numerator really does not matter at all here. It's really just that denominator that you're looking at.
That's number 4 on the.
Is it the exact? It might be. Is
It's
it?
exact.
Yeah, I may have put some of the exact ones on there because I may have put several of these on here because I'll be honest, I didn't look back to compare it, and I forget where things come from sometimes. So we might should just. So that is number 4. I bet I've done that on all. We might just be going through and looking at. Let's see. 8 of them. Oh, you have it easy. Too easy. Yeah. Okay. All right. Let's go back to questions. I'm not gonna go over all. I'm gonna do the ones we did really badly on. Let's see. Okay, so the function f is continuous on the interval from negative 1 to 3. It is not continuous from negative 1. Okay, it is continuous from negative 1 to 3, not with less than sign. It is not continuous from negative 1 to 3 whenever you have or equal to sign. So that tells me it's discontinuous either at negative 1 or 3 or possibly both. Which of the following could not be an expression for f of x? So this one is going to have a discontinuity at just 3, but it's going to be continuous everywhere except for 3. So this could be an answer. Or well, it could be, because the question is saying which one cannot be an expression. So this could be f of x. This one is going to be discontinuous at negative 1. So it could be, this one's discontinuous at both negative 1 and positive 3, which also could be f of x here. So all 3 of those are okay. This one's continuous everywhere because it's just a quadratic. All right. So it's continuous everywhere. So that second part is not an expression.
That's why I see it, and then I missed it. And then I looked over it yesterday. How would we, like, that's number 6 on here. How would we write that?
You don't have to put work for it.
I was already answered.
Yeah, all of the ones from AP Classroom are already answered for you. I don't know why I did it that way either, but I just couldn't go back. And I realized that was happening, but I could not go back and find all of those questions, even though if I just looked at this up. All right, so what? Because it had both, yeah. All right, let's look at 6. We didn't get so hot on it, or I just missed it. Okay, so this is one of the removing discontinuities. Let's see who got it right to congratulate them. All right, so congratulations to all of you geniuses out there that got this one. So whenever you have a function that is defined everywhere except for x does not equal a certain value, then basically what you need to do for this continuity is it tells me there's probably a hole in that graph and I need to know what point I need to put there. So for this one, normally for this we would do like a limit from the left and a limit from the right. There is no left and right here because this is defined everywhere. So what we do is we do the limit as x approaches negative 3, because that's the point we're worried about, it's negative 3, of x squared minus 9 over 4x plus 12. And so the limit, we'll do x minus 3 x plus 3. Factor out a 4 down here, you'll get an x plus 3. These are going to cancel. That tells you there's a hole right there at that point. And so then you just plug in your negative 3. Negative 3 minus 3 over 4. It's going to give you negative 6 over 4, which will give you negative 3. I was doing like Jack there. I was about to do 2 over 3. This is not calculator active for this one. That's your answer. Yeah, so what happens with this graph is you got whatever the graph looks like right here at negative 3. It's got a hole in the graph there. Actually, I should put it down here. And the y-coordinate is at negative 3 halves. Let's pretend like the x-axis is actually up here. So if you put negative 3 halves right here, that just puts a closed circle right there where the hole is at.
Whoa.
I just don't know how to read.
Yes.
So what do you do?
All right, I cannot hear Daniel.
There's like a type of problem you do, like you cancel out the x plus 3s and then you use that equation for something. What is it? Where the x is on the top and no, like they cancel out and then you use the x minus 3 over 4%.
We're using x minus 3 over 4 here. We're just doing a limit.
No, here, this is just like a question.
What's the question?
Definitely no.
I'm not sure
What's the
what you're
question?
talking about. I'm not sure.
What is it? Go ahead. I guarantee I didn't even get it. Was that actually? What is it?
All right, let's see. We did that one.
Like, did you put 3 in the first place?
Okay.
Then I probably don't know the answer.
All right. So these are always hard problems where you got 1, 2, and 3. It's like 3 or 4 problems rolled into one here. So they gave you. We know f of x equals 2x plus 3. Let's see. Let's congratulate our correct one.
Oh, dang.
Good job, guys. Good job. Lots of the same ones. All those green kids out there. I'm not going to pick on anybody else. Unless it was you, and then I would show everybody that I'm not for sure it is. Alright, so. Okay, so you got 2x plus 3 over x plus 1. So 1 says the graph of f has a horizontal asymptote at y equals 2 because the limit as x approaches infinity of f of x equals 2. So, how, are those not the same? Oh, negative infinity, okay. For the limit as x, whenever we need to know a horizontal asymptote, we look at the limit as x approaches infinity. And whenever we just have something like 2x plus 3 over x plus 1, we can do Bobo-Botno ECC here. Exponents are the same, so we divide coefficients, which is 2. So this is correct. Yeah, Bobo-Botno ECC. So your exponents are the same here for your highest exponent and top and bottom. So you just divide your coefficients, 2 over 1. Or you can do 2x plus 3 over x plus 1, and then we divided by x. But that was before I taught you the shortcut. So that's like 2 plus 3 over x over 1 plus 1 over x. These will become 0. So we'll get 2 over 1. I should use limit notation, but I'm being lazy there.
What is the expectation for tomorrow's test when it comes to showing a
Multiple choice, I don't care what you do. If you Guess it right, you get it.
Let's go.
So multiple choice, I don't care. Unless I do want to see some work on some problems like, I don't want to see you turning in something where it's all blank, where it looks like you were cheating off of somebody else. Like, if you turn it in completely blank and get all the questions right, I'm going to be suspicious of you. But, you don't, like, if you show no work on that, if you're doing that in your head, that's fine. On multiple choice. On free response, obviously, you got to show a lot of work on that. Yes. Make sure you know it only applies. Oh, Chandler's asked a good question here. She has asked a very good question. She asked if there's a time we cannot use Bobo-Botno, and there are a few. First of all, can I use Bobo-Botno over on this one?
No, because it's approaching 0.
So do not use Bobo-Botno unless its x approaches infinity. Because I have had people take the entire limits test using Bobo-Botno for every single limit.
That is incorrect.
So they miss every single limit except for the ones that were x approaches infinity. So yeah. And the other times you can't use Bobo-Botno, if I have something like this, the limit is x approaches infinity of x minus 3 over square root of x squared plus 4. You're going to have to divide there because of that square root. Also, if you're doing the limit as x approaches infinity of something like 1 over, well, it kind of works there. It's actually when x approaches negative infinity of something like 1 over e to the x or something. So when you have those e to the x's and you're going to negative infinity, those are the times where you don't want to think about Bobo-Botno. Otherwise, it pretty much works all the time. There. So whenever you do the limit as x approaches negative infinity, for negative infinity, if I were doing either one of these, it would matter if they were positive or negative infinity. If I got square roots or e's, or the other situation is when you got a piecewise function. It matters whether or not it's positive or negative infinity. But for a problem like this, it does not. So this limit still equals 2, even if you're approaching negative infinity as well. Okay? And then the graph of a vertical asymptote has a vertical asymptote at x equals negative 1 because the limit as x approaches negative 1 from the right of f of x equals infinity. So we definitely have a vertical asymptote at x equals negative 1. We do want to kind of think about what's happening here because maybe they're line and maybe it's negative infinity. So I would make a chart. So if we're approaching from the right, we need numbers bigger than negative 1, so maybe like 2. 2 times 2 plus 3 over 2 plus 1 is going to be 4, 7 thirds.
So the test is on paper.
It's on paper. 2 times 1 plus 3 over 1 plus 1 is going to be 5 halves. 0 is going to give you 3. You could do it maybe like 1/2, but those numbers are getting larger there, so that supports positive infinity, so to speak. Yes. However much extra time we end up with at the end of the class. If you need longer. Yeah. Yes. To do horizontal asymptote, you always need to do the limit as x approaches infinity or negative infinity. Right. So if x approaches 0, it is. I was just putting this here to show you cannot use Bobo-Botno on this. Right. Right. Yeah. The only time you're going to use Bobo-Botno is if you're doing limit as x approaches infinity. Sometimes you might just have that question and not related to a horizontal asymptote. They might just ask you to find limit as x approaches infinity of a function. Or if you have, if they ask you for horizontal asymptotes. Those are the 2 times you're going to use Bobo-Botno. I have had students who once I teach them Bobo-Botno, try to do Bobo-Botno on everything. So if I give them the limit as x approaches 1 of x squared minus 3 over x
Instead of finding the limit
squared plus
they
2, they say it's 1 because they would just divide coefficients. So they use Bobo-Botno on everything and do really, really badly. So don't let that be used. Bobo-Botno should only be used like a handful of times, not on like 15 different problems. Yes.
Wait, what do you do? I already forgot. What do you do for negative infinity for Bobo-Botno?
So for if it is just a problem like this where you just have coefficients bigger on the top, bigger on bottom, all you're going to do is just divide coefficients. It doesn't matter whether it's positive infinity or negative infinity; it's going to be the same. It is e's and square roots and piecewise that are going to give you trouble. So, like for example, if I have the limit as x approaches negative infinity of 2e to the 3x. Something like that. So, when you have e's, you're going to be plugging in negative numbers into an exponent. And if you have negative exponents, what do you have to do with negative exponents?
Put them on the bottom.
Move them to the bottom. So with e's, I would do this. I would make my x approaches positive infinity and make this x right here negative. It's going to have that same effect. And then you'll move that to the bottom, so this will be the limit as x approaches infinity of 2 over e to the 3x. And then that would be 0. Because as the numbers get bigger and bigger and bigger, that denominator is going to get bigger and bigger and bigger.
So is something raised to infinity just infinity?
Yeah, so like if you're doing positive infinity on this one, if you're doing 2e to the 3x, if you are doing positive infinity here, 2e to the 3 times infinity would just be infinity. Yeah. So it's only negatives you got to worry about there. So if you have negatives where they're going in the exponents. The other thing you got to worry about, we did some of these. But can I even make up one of these problems? They're so hard to make up. I think I can. I think that'll be fine. So, like on this problem, you can't just divide coefficients. They're not exactly anyway. So these are the ones where like we're going to divide by x squared here and here, but that's underneath the square root. So as x approaches positive infinity, the square root of x squared just equals x. But if we've got x approaches negative infinity, the square root of x squared equals negative x. Yeah, maybe. I mean, I can't remember if it's on there or not, but possibly. So what you would do is like where you divide by x squared here and here, you divide by negative x up here and here. Because x approaches negative infinity.
Oh.
If it was x approaches positive infinity, we would divide by x here and here.
So you gotta pay attention to the limit.
Yeah. So we will get limit as x approaches negative infinity of, you just get negative 1 here minus 5 over x over square root of 1 minus 1 over x. And so anything with an x in the bottom, that just goes to 0 whenever you go to infinity or negative infinity, doesn't matter, right? And so you would end up with negative 1 over the square root of 1, which is just negative 1. The square root of 1 is 1. Yes? So if you have a bigger exponent on the bottom, like, then you're going to get 0 for your answer for those.
But like if it's like 1 over infinity, does that just
Yeah, so like if so what's gonna happen here, like as x gets bigger and bigger and bigger, it's kind of like you've got 5 over infinity and then square root of 1 minus 1 over infinity. And so 1 over infinity and 5 over infinity, that's just essentially 0. Because it'd be such a tiny, it'd be 5 over 1, 0, 0, 0, 0, 0. It would be so tiny, it'd basically be 0. So infinity over 1 would be infinity. Infinity over 5 would be infinity. But if you get infinity over infinity, like we were getting on that, that tells you there's something else you need to be doing. That's indeterminate form. So you should not leave that as an answer. This does not equal 1, and it does not equal infinity.
So if we get infinity over infinity, that means something needs to cancel out that we didn't cancel out.
Yeah, it means you need to do something differently. Because like most of these, if we look at this, like if I plugged in infinity here, I'd get infinity over infinity. But what I need to do is overlap no and divide coefficients. Yes. You won't have, the answer will not be indeterminate. There will be questions where like when you plug the number in, you get an indeterminate form, but that means that you need to do something else. So if you find yourself plugging in a number and getting 0 over 0 or infinity over infinity, that's not going to be the answer. There needs to be something else that you need to do. Does that answer your question? Yeah. So it might happen, but it's not the final answer. All right. It does not equal infinity, and it does not equal 1 like it seems like it should either. It's another like form of 0 over 0. It's indeterminate form. All right, let's see here.
After we finish this, can we go back to like what we did with the 0? When we actually got 0 over 0 and substitution.
I think when we get done with this, we should go back to what we did like the first week.
All right, let's look 11 real quick. Oh wait, that was 11, wasn't it? Or is this?
Yeah, it was.
That was 11. All right, let's go. All right, okay. This one, we only had 2 people get it right. Ethan and Alfredo, congratulations.
Oh, is this the last week? Yeah.
Okay, so this one, this is a very simple fix though. So hopefully after I teach you this, you will know. I've said it, but probably not loud enough. Okay. This is horizontal asymptote. So for horizontal asymptotes, we're doing the limit as x approaches. In this case, I'm doing positive infinity. It would be different if you did negative infinity, but they told you x is greater than 0 here. So you're going to do positive infinity. So you're kind of doing Bobo-Botno here. But you did Bobo-Botno incorrectly because e to the x is bigger than x to any power. Because exponentials eventually are going to be much, much, much bigger. Because a quadratic or even something to the 20th power, it's going to shoot off really quickly at first. But exponentials always in the long run grow faster. So if you have an exponential, consider it to be bigger. Yeah. So if you have an exponential, e to the x is bigger than x to the 20th. It's bigger than x to any power, so this one's going to be 0. So you'll have, so y equals 0.
But it'd be x to the 20th divided by e to the x.
Yeah, so like, you would have, like you would divide everything by e to the x.
Yeah.
And so it's a little hard still to think of because this doesn't cancel, but you got to consider that for gigantic numbers, that e to the x is going to be bigger than the x to the 20th.
Okay.
Even for pretty big numbers, the x to the 20th is still bigger, but when you go to infinity,
So
e to the x is
e to
going to
the
be
x is kind of like infinity.
Yeah, e to the x trumps x to any power. So it's bigger than
So
x
that's
to n
fine.
power.
So like if you replace.
Yeah, so this will be 0 here, and 0 here, you'll get 0 plus
Does it matter if there was like an e to the power of 2x or e to the power of x squared? Or do we even need to worry about that?
only if there are other x. Like, for example, if I had e to the x over e to the 2x plus 1 or something like that. If you got that 2 here, this one would be bigger on the bottom, it would be 0.
Wait, really?
If I was in the limit as x approaches infinity.
But doesn't infinity, don't the other numbers not matter with infinity? Because 2 times infinity would just be infinity.
But don't think of it like plugging in infinity. Because like for any problem, even if I had like x plus 1 over 2x minus 3, if you plug in infinity, you're going to have infinity over infinity. Right? So like if I plugged in infinity here, I would get infinity over infinity. Which is indeterminate. It doesn't tell you the answer. This one here, this one would be exponents are the same, divide coefficients, you get 1/2. If you're doing limit as x.
And that's what was on last.
Exponents, not the coefficients, but the exponents. Yeah.
And that's your horizontal axis. For that.
Yeah, your limit as x approaches infinity is your horizontal axis.
The vertical asymptote, you plug in the numbers to the graph. Right.
Oh, I get it.
The first.
Let's go over one more on this. Yes.
I'm not even for the,
Yeah, like
for the one
to the 2x, would you divide that by e to the 2x, like, for every one?
You could, yeah. Like if you did that, you could divide by e to the 2x, e to the 2x, e to the 2x, and then here, like one of the e to the x's would cancel, so but you'd still have 1 over e to the x there. So you could do it that way. Yeah.
The test is on the curve, right?
The weird AP.
Yeah.
You all fail?
Not like a curve. Like you can all fail, or you could all make 100.
Could it be an exponent?
I doubt either of those will happen, or at least I hope not for the failing part. But your grade does not depend on how the other people in this class perform, but it does depend on. So it's not. Yeah, it's not a bell curve. So it does not depend on how the other people in this class perform, but it will be curved where it's kind of compared to like how they normally grade the AP exam, kind of. It's my rough estimate of it
And
anyway.
we'll have test corrections.
Not for credit back.
But not like for separate grades.
It'll be for a separate grade.
Will it be for quiz grade?
They go in as like a quiz grade. It goes in like the quiz homework section.
I think it should go as an FRQ.
No. No. All right, let's look at this last one, and then we're gonna.
Oh, no, you're right.
Okay, last one here. All right, so several of you got this one right. Good job.
I'm up there.
Okay. All right, so this is intermediate value theorem, which it doesn't tell you this up here. Whatever it is. So whenever you see F5 is less than 6, less than F7, you should be thinking intermediate value theorem. So yeah, 6 is in the middle of these two values. And so it said, which of the following statements provides sufficient additional information to conclude that there is a x equals c in the interval from 5 to 7 such that f of c equals 6. So whenever you do intermediate value theorem, I was doing this earlier, there are 3 things you have to show. Number 1, you have to show that it's continuous. Because if your function is not continuous, intermediate value theorem does not apply. Number 2, you got to show that your value is between these two f of whatever values that you have. So they've done that here, right? And then you have to show, make your conclusion that by the intermediate value theorem there must be a value blah blah blah. They've made that conclusion here. What part have they left out? they did not tell you f was continuous, so f must be continuous. Just being defined does not mean it's continuous. Just increasing does not mean it's continuous. It has to be continuous. You don't need to know anything about the limit.
C looked right, but D had a lot more words.
Yeah, that's what I heard.
No, but it's already
Answer
said
the most words.
and it asked for more, right?
Yeah, but like,
Yeah,
if it already says D, that means D.
so like they've already said that f of c equals 6. So if f is continuous, that tells you that the limit is also 6, but like you don't have to know that. So. All right.
That was Jay today.
Good. How about yours? Okay. So how long do I need to give us to go over these? 1, 2, and 3 are ones you got to look at.
I don't remember how to do a lot of this.
All right.
Can you do like a little
All right. Let's see. Okay. Let's look at what I've given you here.
Oh, I know.
Okay, so this is blah, 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 no. But you do have to consider positive and negative infinity separately. Because if I'm doing the limit as x approaches negative infinity of f of x, which function am I using? The top, the middle, or the bottom? Top. So limit as x approaches negative infinity of x minus 5 over x squared minus 3x. What do I get for that? 0. Now, if this is for response, what else have I got to write?
We do have to write the limit.
What does the question ask you for? Horizontal asymptote. So you have to say f has a horizontal asymptote at y equals 0.
Make all the x's negative and you can do that.
It doesn't make a difference. It's only whenever you've got like exponents that the variables are going into. You could, but you don't have to.
Oh, it's raised to
Yeah.
x. Okay, that's fine.
Yeah.
You need the work. This can be done in your head.
I would show this part so it shows that you know that you're using the correct section. Yeah, I would write this. I would write it like this to be extra safe. Make sure you give y equals 0, not just 0. Don't say at 0. It's got to be. Yeah. It'd probably be better if you didn't abbreviate all of that, but I'm being lazy.
When we took the like number 2 thing, but then I remembered that I probably
Yeah.
The one thing I want to know is can we abbreviate IDT? I don't feel like writing all that out.
I'm going to say no until I get further confirmation on that because I feel like the answer might be yes, because a lot of the stuff AP puts out, they put IVT on. Like in their answer keys, they'll put IVT. So I'm thinking maybe it's okay, but I don't want to tell you that and then you do it on the test and you lose a point because of it, because that would be bad. So until I get further confirmation, let's say you got to write it out. Also, the other thing about that is if you call it IVT all the time, you might forget what it actually stands for. Like, SCUBA stands for something. It's an acronym. I'm pretty sure, I don't know stands for, but scuba is an acronym.
Colombian underwater.
It's not there.
Colombian underbus.
NASA is an acronym.
Self-contained underwater breathing apparatus.
Self-contained underwater breathing apparatus, scuba.
NASA stands for National
Long.
Aeronautics and space, yeah. But a lot of times if you use the acronym a lot, you forget what it actually stands for.
Underwater breathing apparatus. Sizing.
See?
Sizing.
Scuba self-contained. This is such a cow. They're making stuff up.
Wait, why do you have to add limit? Why did you put limit as the first name instead of limit as a?
I'm just showing that if I do the limit of this piecewise function as x approaches negative infinity, then I'll just use that top function.
So if I don't write limit again after equals 7, you need to write x coming to
Yes. Because if you just put x minus 5 over x squared minus 3x, like it has to have limit notation until you've either plugged something in or you're getting the answer. Yeah, so it doesn't need it in both places. All right, what do we do for the second part? It is blah, blah, blah. No. So this has a 1 in front of it. 1 over 2. 1/2. So F has a horizontal asymptote at y equals 1/2. And you actually could wait down here to the bottom and say F has horizontal asymptotes at y equals 0 and y equals 1/2. Just make sure you write that out. Because a lot of times we'll do the limits right and forget to make that conclusion. Okay? Okay, so this is a yes, but it is also very unlikely that a question like this is going to be on multiple choice, right? So, why is it a yes?
Because
Because the function is continuous throughout the
Okay, so we could say C of t is continuous, because what are we planning on using here? This is intermediate value theorem. When you see, is there a time where this happens?
Yeah.
It's usually going to be intermediate value theorem. So we're going to say C of t is continuous. We're going to say C of t is continuous even if we don't know why. But up here, C of t is really just a quadratic here.
And then T of 0.
Right, so we're looking from 0 to 5, so we'll find C of 0, which Jack is telling me is 161. This would probably be calculate. Yeah.
I did it. It's
161. And then, you're right, it'd be 6 times. It'd be 6 times, or 7 times. 7 times 23. Yeah. And then you'll also do C of 5. That is going to be 23 times 6 times 17. 2,346.
And C of 0 is less than 2,000 is less than 2.
Alright, so by the intermediate value theorem that we're going to write out just for safety here and not put IVT. He's going to write IVT.
Can we like abbreviate each word?
Since,
By IVT.
just write it out.
Yeah.
C of 0 is less than or equal to 2,000.
It'd be less.
Whether or not you put the, yeah, if you put the or equal to's here, it doesn't really matter. Leave them off, put them there. It doesn't matter, because it's true either way. I think I've done it both ways.
That's how I
Since 2000 is between these two values, and then you're just restating the question. Is there a time for 0 to 5 weeks where 2,000 cars have been produced? There must be.
You want must be or can you say there is?
You're probably already through it. You say there is. There must be a time, and I just copy it from here, t, for 0 less than or equal to t less than or equal to 5 weeks, where 2,000 cars had been produced.
Well, I think we'll look at that.
I don't even write that much in the essay.
I'm gonna go out of our way.
So the whole like 0 is less than or equal to t, 0 less or like less than or equal to 5. That's the one that we also just do brackets, right? You just do brackets and then 0.
You can't do brackets there now. Oh, you mean right here, this part? Oh, so I was looking at the wrong. Yes, you can do brackets there. So if you do 0, 5, that's
What's
okay.
the difference between these and brackets? Like, well, those you put brackets.
Brackets are interval notation, and then this is just your inequality notation. Brackets is like having an or equal to sign, whereas parentheses is like a less than. So either one of these is fine. AP is going to use that notation, like both types of notation. It just depends. So we need to be able to do both of them. And like even if they use interval notation here, it doesn't matter. You could use either one of these here. I just copied it basically word for word because you're less likely to make a mistake if you do that. Okay. Oh. All right.
Except for the first one.
I remember, but I don't.
All right.
Sine of x.
Okay. I think I forgot to erase some of my work. This stuff right here would not actually be there. So I'm gonna leave it.
Oh, so that's not part of the problem?
Yeah, that wouldn't actually. That's not part of the problem. I forgot to erase some of my work on this one.
So sine and cosine are always continuous, right?
Sine and cosine are always continuous.
Oh, and then it's like tangent is uncontinuous at what it's
Wait, how do
Yeah.
goes to and 3 pi over 2.
Okay. So if you're thinking on unit circle, okay, on unit circle, sine's continuous everywhere. But I do have this issue at like pi over 2, sine has to meet up with tangent. So sine of pi over 2 is 1. That's right here. Yes. I mean, I'm not going to give you something like sine of 5 pi over 6, but you need to know the basics. You need to know the first quadrant and 0 pi over 2, pi 3 pi over 2. You need to know these points here and the points in the first quadrant. All right. So I've got that wrong. This is 0, 1 here. So sine of pi over 2 is 1. Tangent of pi over 2 is sine over cosine, which is 1 over 0, which is undefined. So you've got a discontinuity at pi over 2. So x cannot equal pi over 2. Because sine of pi over 2 is 1, but tangent, because you're skipping down here to tangent, is undefined. So for you to not have a discontinuity, they both have to equal 1. And they don't. Tangent could have a tangent, we remember, is sine over cosine. So anywhere that cosine equals 0 is going to give us a discontinuity for tangent. And so cosine equals 0 at pi over 2. It also equals 0 at negative, oh no, it's negative pi over 2, but 3 pi over 2. All right. So tangent of 3 pi over 2 would be negative 1 over 0, which is undefined. So x cannot equal 3 pi. over 2, because tangent is undefined there. Also, since it's undefined when you're considering tangent and cotangent, obviously, since tangent's undefined, you've got a discontinuity there. Cotangent is sine of x over cosine. No. No. Back it up. Cosine of x over sine of x. So cotangent is going to be undefined whenever sine equals 0. And sine equals 0 at 0 and pi. But 0 and pi aren't between 3 pi over 2 and 3 pi. But it equals at 0, pi. If you kept on going, this would be 2 pi, 3 pi, 4 pi, 5 pi, any increment of pi, right?
Why is it going backwards? I thought there was another.
It goes this direction. Yeah, you go counterclockwise here. Start right here at the x-axis and go counterclockwise. This will be 0, pi,
Yeah.
2 pi, 3 pi, 4 pi, and so on. So x cannot equal 2 pi. X cannot equal 3 pi. X cannot equal 4 pi, even though 4 pi is getting out of our range, so we're not worried about that. So these are the values we cannot have. So we want to know where it's continuous. Is it continuous from 0 to 3 pi over 4? It cannot. So I would do this. I think of the unit circle at pi over 2. We can't have that value. 3 pi over 2. We can't have that value. And then we can't have 2 pi or 3 pi, which is right here, but it's okay for it to be 0. So I'm going to be careful marking that out. So 0 to 3 pi over 4, 0, 3 pi over 4, that includes this, so it's out. At pi over 4 to pi, that one also includes that pi over 2. That one's out. 3 pi over 4 is right here. And 7 pi over 4 is right here. That includes 3 pi over 2. That one's out. And so 9 pi over 4, 9 pi over 4 would be a full rotation and back on the same place as pi over 4. And to 11 pi over 4, which would be here. It does include that marked out spot, but we're not using that. We're only using cotangent right here. So it is going to be, I might not should have marked it out on it. What you really should do is you should do a separate unit circle for each section. So like for A, you can't have this or this. And so, or you can just think about the number values, like 2 pi falls between 9 pi over 4. Like 3 pi over 2 falls between 3 pi over 4 and 7 pi over 4. Like if you're thinking about the fractions, because it would be 6 pi over 4. No, I would. It would not take me as long. I would list these 4 right here, and then I would check to see if it falls in those ranges. I only do it when it's necessary. I usually do what I've done right here and like make myself a little sketch. All right, I think we went over more or less. All right, 12. Look at 12.
I know it's 1 for that one.
Is that velocity like distance divided by time or something? That's speed.
Let me do that. Daniel, you want to give us a bathroom pass? And get a jar if it's necessary. So let's be nice to our friends, okay? Alright, so Okay. The graph above shows the position x of t. This is position of a particle as it travels along the x-axis. And so I probably should have put at time t. This is time right here. Which of the following gives the velocity of the particle at t equals 8? So t equals 8 is this point right here. So one of the answer choices is 1, which is just the value of the function here. Is that correct? No, because that's position.
It can't even be negative. It can't be 1 because it's going like. Yeah, it could be. You could have negative velocity.
Yeah, you can have negative velocity. You can. Okay. So position's like distance traveled. So whenever we want to find velocity, we would do the change in position over the change in time, which position is on my y-axis. My time is on my x-axis, right? Which is slope. So velocity is slope. Which one of these would give you the slope that you want? It's either C or D. Those are slope formulas.
1.
So like you could actually find it from this graph, but the answer choices are not. Okay, so the answer is C, because these would be the points 6x of 6 and 9x of 9. That would be the slope between those 2 points. So this point right here is 9x of 9. Like we could tell it's actually 0, but they didn't do that here. Right? And then 6 is up here, so this is 6x of 6. Because you are so smart, you're going to understand this in many different
They're
representations.
asking you that. Okay, they can literally just put 3. That's it. That's all you have to do.
Fine, take calculus again over in college. Okay, 13. This is similar, but they didn't give you a graph. Alright, a bike is ridden on a straight road, and the distance traveled by the bike after time t is given by the cubic function f. We don't know what f looks like. It does tell us it's cubic. The only thing important about that is it's continuous, right? Where f of t is measured in feet and t is measured in seconds for 0 to 9. Of the following, which gives the best estimate of the velocity of the bike? So, t is on our x-axis. It's in seconds. And our distance, which is in feet, is on the y-axis. So I don't know what this is. It's some sort of, okay. So f of 7, that's just going to give you distance. B, this is nonsense. It doesn't give you anything. It's the distance divided by 7. But there's no real reason to divide it by 7. I guess it's like your average speed of the person. Alright, this is slope, but it is slope from here to here. Right? So it's the slope from way far away. But let's say 7 is actually about right here. Right? So if we went from 8 or 6 to 8, we'd have this. I realize those look really close. It just happened to be that way. But the closer you are to that point, the better your estimate is, right?
Yeah.
So D would be your best answer.
So we would just pick the two numbers that are closest.
Yes.
Wait, 14 is calculator active, right? In Calc. 14 is definitely calculator active.
Yes. Okay, I really need to show you this.
Yeah.
Well, I hope you don't run out of time.
Then I would think calculator.
Because I really need to show you this.
Anytime there's just a
All right, this is calculator active. You can't do this without the calculator. None of you can. I can't do it without the calculator. So, you are doing, you want to see where this is continuous, which means you need to look at the limit from the left of 5 and the limit from the right of 5. This is multiple choice. I'm not worried about showing all my beautiful work there. Which means I'm going to plug 5 in to this for my limit from the left. And then I'm going to plug 5 in for my x's here. So I got c times 5 square root of 5 squared minus 3 plus c. I would simplify just a little bit to make it easier to type in. So you got 5c. This is going to be square root of 25 minus 3, so 22 plus c.
And then you plug that into it.
Yeah.
You'll
So
probably use X's instead of C's, right?
for the yes, I will probably use x's instead of c's. So to solve on the calculator, if you do F2 algebra right here, we're going to type in the equation 5 minus cosine. I'm just going to use the x.
Wait, what is it?
Yeah.
Oh, that's what I was saying.
Oh, it is. I'm sorry.
Can you restart? How do you do that?
F2 solve.
Just F2.
5 x yeah. If you don't have the 89, it doesn't have that option. Plus x. Then once you type in the equation, what have you got to put? Comma x close parentheses. Oh, then I've got this junk. That's not helping me. What should I do instead?
I don't know.
Green button, enter. 0.192.
That's B.
That is B.
So
If for some reason you can't get this to work, graph these two in y equals, put the first part in y equals, the second part in y equals, see where they cross.
how will you see the comma X?
Yeah, that will, if you get something like that, it'll be on the calculator.
This high, how would you see where they cross?
Just go to the graph.
And just like click the trace button.
No, when you're on at the graph, I don't know if I've got anything in here to show you. When you're on the graph, I don't have anything in here for it to work right now. But if you hit F5, which is math, there's an intersection function, which is 5 right there.
Would you like me to bring my homework tomorrow before?
So we did this together, so I'm just going to give everybody credit for this assignment because we've done it together. And so there's nothing you have to turn in tomorrow. Just show up and take your test. I've got virtual office hours if you're studying tonight